Dependence of dissociation constant with the formation of equilibrium constant. In a formation equilibrium constant reaction, the reactants and products are written at LHS and RHS of the equilibrium sign respectively. So Kp divided by RT delta Ng and Kp is equal to Kc into RT power delta Ng. For the same reaction, the dissociation equilibrium constant of the product in the place of reactants and reactants in the place of products being written at the LHS and RHS of the equilibrium sign respectively. I wish to show you how the dissociation of strong acids and weak acids are happening. Let's move on. I am trying to add the strong acid or weak acids with water. You are able to see the reaction is happening. Let's see what is the reaction. In general, your acid H hydrogen with acid, if it reacts with water, it will become A minus and H3O plus. This is the overall reaction. You will be having A minus and H2O plus. It's become acidic more. Over here, strong acid will react the same as indicated by the general nature of acids. You got H3O plus ions and A minus ions. Whereas if it is a weak acid, your HA will become like this. But there is a back-end position, equilibrium position is happening. You are able to see an equilibrium in the weak acids. Now I am checking with the strong acids. This is the strong acid HA, which is going to react with water, and here is the water molecules. And once if it started coming in, you are able to see it started becoming H plus and H3O minus ions. This is how the reaction is in the strong acids. In the constant K is equal to H3O plus A minus divided by HA. It's greater than 1. If it is weak acids, you are able to see this is the weak acid. Here there will be an equilibrium maintained. You are able to see an equilibrium is maintained. Water molecule is available still. This is how the weak acids react with water. So the constant is lesser than 1. In such case, the equilibrium constant of the dissociation equilibrium reaction, which is known as the dissociation constant, and is found to be the reciprocal value of the equilibrium constant for the formation equilibrium reaction. For example, consider the formation equilibrium reaction of sulfur trioxide from sulfur dioxide and oxygen gases. The equilibrium constant Kc is given by Kc is equal to SO3 square divided by SO2 square into O2 dm cube per mole. In the dissociation equilibrium reaction of sulfur trioxide, the reactants become the products and vice versa. So the equilibrium constant of the dissociation equilibrium is Kc dash, which is given as this one. So it is equal to 1 by Kc mole per dm cube, where Kc dash is considered as the dissociation constant of sulfur trioxide gas. Usually the equilibrium constant of the dissociation equilibrium is the reciprocal of the equilibrium constant of the formation equilibrium reaction.